Okay, so let's get started. Does anyone have any questions from yesterday before we move on today? Okay, so just a reminder, over here on the calendar page is where I've got the notes. So today we're going to be talking about data types and variables. And here's the drill for today, which I think we should cover enough stuff to do it. And then I posted yesterday's lecture over here, so you could watch it if you want, and then I'll have today's up here as well after today. Okay, so our topic is data types and variables and how to do some computation. And so basically some arithmetic computation like adding and subtracting and multiplying and stuff like that. So first, though, let's talk about the general structure for making a Java program. And we've already seen some of that with the Hello World program that we did yesterday. So maybe I'll type some of this part. So in the general structure, we have at the top, we didn't do this for the Hello World, but you're going to do this for most of your programs, is up at the top of your program. Generally, you'll have these import statements. Will be import something. So one we're going to be using pretty soon is java.util.scanner. So this would be like, this is my file. Then this would be at the top of the file. And later on, when we talk about packages, that would be at the very top of the file. But for now, this would be generally the first thing you put in the file. So we'll say more about this later, but basically this is saying what other libraries do I want to use that have already been written for us. So people at Oracle and other places have written code already, and so there are lots of places where you want to use what someone else has already done. So for example, we're going to use this scanner thing that other people have written, and it's where you can get input from the keyboard. So to say I want to use this existing code, we say import followed by the name of the package. So this thing is called a package. And basically it's other code someone else wrote. Let's see. So then after that, and you might have lots of these, so we'll say about, basically as we go through the class, we introduce new things like how to draw graphics or something, we're going to add new imports at the top. And then when your program starts, you have this thing, public class, whatever the name of your class is, and then the curly braces. And then we had previously said that this class name has to match your file name. So this should be in a file that's named classname.java. So yesterday we had like hello world or something like that, so then it would be in hello world.java. If you're calling this thing program 37, then you'd have program 37 here and program 37.java. So you have to make sure that these things match up, or you might have problems compiling. And then we have curly braces, and then anytime you have a curly brace, like a left curly brace, there should be a matching right curly brace. And then, just like parentheses, it groups something together. And so this says this is where the body of this class exists, and so we'll say what a class is later. Class stands for classification, so it's like a way to organize things, not class like in teaching a class. And then inside this thing, we'll see that we can use these keywords public or private, and then there's another one, protected, we'll say later. But we can put one of these keywords here, and we'll also kind of say more about it later, but as it implies, public means you can access it publicly, so from outside of the class you can access it. If something's private, then you can only access it inside the class. So for now, once again, this thing doesn't really matter to us until we get to later concepts. So you can At this point, use whatever you want. I'll just tend to use public all the time for now. And then we're going to be able to make a variable name. This thing over, oops, sorry, I missed something. We have data type. So this whole thing is called a declaration. And so once again, we'll do this in more detail, but just kind of give you an idea of what the structure is going to look like. Is we have to specify what kind of type this can be, and the type is going to say if it's a number or characters or whatever. And then you can pick a name for a variable. And if you do this, then this variable exists inside this class. And you can do as many of these as you want. So you could do like private other variable. We do have to stick semicolons at the end of these lines, so there are semicolons here. And then we have this other thing called a method, and we saw one of them already, public static void main. So this thing that we wrote before is called a method. Sometimes it's also called a function, but in Java, usually the word method is used. And the basic idea is you have something that ties together some related code. In this case, there's a special method called main, and that's the starting point where your program starts to run. So main is special. It's where your program runs. And you can add other methods, and so I could add, for example, public. Generally, we won't have static, so we'll talk about static later. Public, something like int, compute square root. So just as an example, I could make another one that's public. We'll say more about int here later, but this is going to be the return value. This is the name of the method that you get to pick, and these are the values that come in. So essentially this is saying, let's make something called compute square root. It'll take as input some number n, and then inside here we would put the code that actually computes the square root of n, and then sends it back out. So once again, we'll say a lot more about this later. It probably doesn't make too much sense right now unless you've seen some of this before in some other programming language. But this is the kind of structure that we're going to be making, is we'll have this class inside this file, and we'll say public class, whatever your file name is, and then we'll start adding these things in here. So to start with, we're going to mostly just use main for like the first 2 weeks or so, as we'll kind of just stick everything here inside main. But then after that, we'll start branching out to other stuff in here. Okay, so just a little bit of terminology. This whole thing would be our code or our program, so everything inside this whole file. I've already talked about variables, and so a variable is kind of like a math variable. You can pick a meaningful name like velocity or x and y or something and assign it to a value. So it's sort of like a math variable. We already talked about this term method. It's this group of code that does some specific thing. Let's see, I mentioned class already. Another term you'll see is object. Java is considered an object-oriented programming language. So we'll see that later where we can create objects. There's like this analogy with the real world, which anyway, I'll leave that till later. When you have a line of code, like we have seen this one, system.out.println, This line of code is called a statement. Some parts of our program are special keywords or reserved words. So for example, import is a keyword. Or reserved word. And so what reserved word means is you can't use it for your own purposes. So like right here, for example, you got to pick what the name of the class was, and we called it Hello World or something. And all this is saying is you can't pick the word import as your word over here, otherwise Java is going to get confused. Does it mean import a library, or does it mean it's the name of your class? So you can't use words like import or class or public and sort of the other things that make up the language you're not allowed to use for your own names. Okay, so let's do a few examples of a little bit more about printing stuff out, and then we'll move on to defining variables and using them. So I haven't fixed up my Dr. Java yet. I was just messing with it a little bit, but I didn't quite figure it out yet. So my Dr. Java still doesn't work, so I'm going to use like a different program here. I'm going to use TextPad. So you don't have TextPad on your computers, I don't think. But it's pretty similar. So I have this text editor, and then instead of clicking on the compile button, I have like this thing here, Control-1 to compile. And then to run it, I do Control-2, and so there it runs. So it looks a little different for mine because I haven't fixed up my Dr. Java program yet. But essentially it's the same, except for I don't click on the same buttons. And the editor looks a little different. So actually, now that I'm in here, I was going to try to make a bigger font. Okay. Okay, so to start with, let's say a little bit more about what we can do in this system.out.println. So we've seen that whatever is inside these parentheses gets output to the screen. And so just to add on a little bit more, let me get rid of this just to clean it up a little bit. Everything inside the double quotes is called a string. And so a string is considered a sequence of characters. And if I try to output something like this, then something bad will happen. Okay, so let's say I would like to output a quote, and the quote is, or what we like to output is, a famous politician once said, and then the quote that he said is, if we do not succeed, then we run the risk of failure. This was Dan Quayle back when he was vice president, so he was well known for making some entertaining quotes. So what we would like this thing to output is, a famous politician once said, quotation marks, if we do not succeed, then we run the risk of failure, end quote. So if I try to run this, it's going to cause problems. So let's try to compile it first. So I'll hit my button here. And so I try to compile it, and it says there are 11 errors. And so this is pretty common with Java programming, is if you have one error, then there's like a cascade that causes multiple later errors. And so don't be discouraged if you start your program and it says you have 100 errors or something, because there might just be one error that causes them. And that also means don't start at the bottom error. When you have this list, go up to the very top and then start with the first error, because that could cause later errors. So these error messages sometimes are helpful and sometimes they're a little obtuse. In this case, it says it was expecting a right parentheses on line, whatever line this is, line 18. So it's this line. So it might seem a little strange. Well, I have my parentheses. Here's my left parentheses. And there's my right parentheses, so it looks fine. So if you just look at what the error message says, sometimes it's not exactly what's really wrong. And so does anyone know what problem I have with this print line statement over here? Yeah, exactly. And so it's got this double quote here, and it's confusing it because I really want it to print this double quote. But what Java is thinking is that this double quote matches up with the first double quote. And so it says, all right, this whole thing is my string right here. And then what comes after it, it's interpreting as actual Java code. But it's really, Dan Quayle's quote. So there's a thing in most programming languages, and it's called an escape character. And it says if you see the escape character, then whatever comes after it next, interpret it literally. Don't interpret it as like a control character. And so in Java, the escape character is the \/ key. So it's not the /, it's the \/. So the / is the one with the question mark. So it's not that one. It's the \/, which is right underneath the backspace key or around there. So if we put a \/ here, then this tells Java whatever character comes next, actually print that character. Don't interpret it like it's an end quotation mark. And then we have to do the same thing for this one right here. So we stick a \/ in front of it. Whoops, I hit the backspace. And so now if I compile it, all of the errors go away, so there really weren't 11 errors. And then it runs and it prints out the quote. You might have, I saw at least one person who did this, where if you stick a new line in here and you just hit a carriage return so it all fits on your screen, then if I try to compile it, then I have problems because Java doesn't know what to do with that line break that I stuck in here. So you can't just stick an arbitrary new line inside your strings. So just warning, so you'll tend to have things that just run off the side of the screen. That's probably the easiest way. If you actually want to put a line break in your output, you can do that with these escape characters. So the other advantage of escape characters is you can use them to output these invisible things where you can't type them on the screen. So like if I wanted to actually have a line break right here, I can't just hit enter and make one happen. But there's a special escape character, and it's \n. And so if you see a \n, then this means new line. And so right after the word said, then there should be like you hit carriage return, and it print the quote on the next line. So if I compile this one and run it, then here we can see that right after the word said, there's the line break, or the new line, and then this came after it. So just a couple other escape characters. I don't want to spend a ton of time on it, but I could do, if I actually want the \/ character literally to be printed, then you can use \\. So now here I see the actual \/ character. There's only one of them there. Sometimes you'll use this if you want to specify like a directory name and you have like folder1 / subfolder or whatever, then you have to use 2 backslashes to make 1 \. And just one more, if I do a \t, then you can see it put like a tab in there, and so you could tab with a \t. Okay, so that's just a little bit about printing stuff and then doing escape characters, which you probably don't have to do a lot of these escape characters. If there's one you're going to use, it's probably the \n, just to stick new lines in there. I should also briefly mention there's, instead of system.out.println, there's also system.out.print without the ln on the end. So I'll just print hello and see what happens. And so if I have the print without the print ln, then here the cursor stayed right here at the end, and then the next thing that's being output, if famous, just gets concatenated right here, all squished together on the same line. And so if you have a print without an ln on the end, then the cursor just stays at the end of that line. But if I change this from print to print ln, then after the print ln, it adds a new line, and so now the famous got put on the next line. So if you want to control what's on the same line versus not, then you can do combinations of print and print ln. Okay, so any questions so far? Okay, so nothing terribly exciting yet, but just printing stuff to the screen. The next thing we should talk about is making identifiers. And we've already been doing this. An identifier is something where you get to pick the name. And so far we've seen one identifier, that's the name of the class. And there are some rules for identifiers. The rules are that it must start with underscore or a letter. It can contain digits, but not other characters. In particular, no spaces. And it's case sensitive. So here are some sample identifiers, and some of them are not valid. Okay, so let's say I tried this as an identifier. Is this a valid identifier? Yep, that one's good. How about this one, F03B? That's good too. How about 1231? Nope, can't do that because it doesn't start with a letter or an underscore. How about %foo? Nope, not allowed to have percents in there. 9foo? Yeah, nope, not allowed to start with a digit. Underscore X underscore. That one's okay, even though it looks weird. So probably wouldn't be recommended to use it, but you could if you wanted to. Underscore asterisk underscore. Nope, yeah, can't use that one. Okay, so there you go. You know the rules for making identifiers. And where you have to be careful is it's case sensitive. And so I have seen people do something like this, where they call one variable, they make a variable or something called speed, and another place they make capital speed. And so Java treats these differently. As far as Java is concerned, speed with the lowercase s is different from speed with an uppercase s. So if you've defined both of them, then they would be treated as totally separate identifiers. Okay, so what we're going to do in a minute is tie together identifiers with data types. But let's say what data types we have first, or at least some of them. So a data type specifies values and operations that are legal. And so we have kind of maybe 3 general categories. One category is numeric types. Another category are like string types. And really we'll just use one string type. And then the third one is our own user-defined types. And so it turns out that when we do that thing class, like up at, back here where I say public class whatever, it's actually defining a data type of this class. Okay, so let's start though with the numeric types, because that's kind of the foundation for most of our operations. And so out of the numeric types, we have two subcategories. We have integer types and floating point. And the integer types, just like it sounds, can represent integers like -1, 0, 1, 2, etc. And then the floating point types we use to represent real numbers, so like 3.1 or 7.89. Or we could also have these represent 1, but it would be like 1.0 as opposed to the integer 1. So if you make something an integer type, then you can only store integers. You can't store floating point numbers. And if you make something a floating point type, it could store integer values, but it would be using a different representation to store it. So that's something to keep in mind. All right, so what are the different integer types? So now if we dive into integer types over here, here are some types available. There is byte, short, int is the one we're going to use most of the time, and long. And so a byte takes up 1 byte of storage, and we can use that to represent numbers that are integers from -128 to +127. A short ends up taking 2 bytes of storage, and we can use that to represent numbers from -32768 to 32767. The int uses 4 bytes, and we can use that to represent numbers from about -2 billion to about +2 billion. And then the last one here is long. That uses up 8 bytes, and we can use that to represent bigger numbers, or a bigger range of numbers. -9 something something something. Let's see. So like -9, this many places of digits, up to positive, about the same. So depending upon which one of these data types you pick, byte, short, int, or long, we can store some integer number, but the number of bytes of storage limits us to how many values we can store, like data range. So most of the time, you'll probably be using an int, which can store, -2 billion to +2 billion. So assuming your program doesn't need to operate on more than that, then an int should be fine. And that's kind of the default you would normally use. But if you had some application where you had to store more than 2 billion, had to store 10 billion or something, then you would use a long instead. And if you knew that your program was always operating on like little numbers, like between 0 and 10 or something, then you might use a byte or a short instead. So the reason why you would pick the appropriate data type is some take up more space than others. So if you're trying to be efficient in terms of how your program runs, then you should use the data type that corresponds to how much space you really need. So there's no point in using a long all the time. If your program is only going to store 1, 2, and 3, then essentially you're wasting 7 bytes of storage for every number that you've got. And you might say, yeah, who cares about that when you've got gigabytes of memory? But if you're going to have like a program that has lots of data it works on, then it can add up. So it depends on your application, but why not use the storage that most closely matches your needs? This also does mean, though, you have to be a little careful, because if you do make something an int, and then 99% of the time it's numbers between 1 and 1,000, but that 1% of the time you get something that's supposed to be 4 billion, then it'll work most of the time, but once in a while it'll mess up. So you have to be careful that could happen. Let's see. We actually have two other kind of integer types, but they're not really thought of as integers, and those are char, and that's used to store. That takes up 2 bytes, and it's used to store characters. To represent a character, you put it in single quotes. So a character is used to store, I should say, a character, or one character. So by character, I mean like a key you type at the keyboard, and you represent this inside single quotes, not double. And so if I have single quote A, for example, then this corresponds to the code. If you remember yesterday, we were talking about you have these sequences of bits that represent different letters that people have agreed upon. This would represent the code for the letter A. And if I have another one like exclamation mark, I could put that in single quotes, and that would be the code for an exclamation mark. So we've got codes for all the letters you could type, as well as things you can't really type, and then codes for funny ones like what's like I'm trying to think. What are the, like, if I have like an O with the dots over it, what's that called? The umlaut. Thank you. So stuff like that. They're like different codes for some of these other characters that you might have a hard time typing. Okay, so char, single quotes, not double. If you have double quotes, that's used for a string, which is a little different. The other kind of integer type that you don't normally think of as like an integer is there's a type called Boolean. And this only takes up 1 bit, and it's used for true or false. And when you assign the Boolean, you actually use the word true or false, and it can only store something that's true or false. It's named after George Boole, the guy who studied this. And so it's not too common. We'll actually make a Boolean variable, but we'll use Booleans all the time when we evaluate something and we figure out if it's true or false. Okay. The other kind of types we have, so if I go back up here to floating point, and then we have 2 kinds of floating point types essentially. We have float and double. And both of these are used to store numbers like 3.1 or 7.9 or something. And the difference is float uses 4 bytes and double uses 8 bytes. And so I didn't write the range down, but basically with the double you can store like a much wider range of numbers than a float. But anytime you need to store some kind of number with a decimal point and values after the decimal point, then you would use float or double as your data type. And probably I'd say most people tend to use double for whatever reason. Maybe it's just a little more convenient. Okay, so that's these numeric types. The other type is the string type, and the type for string is just string, and you have to use an uppercase S. And a string is used to store a sequence of characters. So it's a sequence of char. And for strings is where we use double quotes, not single quotes. So if I had double quote hello, then this is a string where essentially I've represented a char for H, a char for E, a char for L and O. And so it's all 5 of those things all strung together. Okay. So if I take my data, and then the last one here is user defined, and we'll do that later. So for starters, we're going to mostly focus on numeric types and the string types. So to make a variable declaration, I put the data type first, followed by a variable name, or I should say identifier. And then a semicolon, or I could optionally do equals initial value. So let's give a couple examples. Let's say I wanted to store how many students are in the class in some variable. Then, well, the number of students in the class, you don't have fractions of a student, so I can use int as my data type. And then I might call this something like num students. So this would be saying create a variable called num students, and it can only store integer values in it. And if I wanted to, and if I just do it like this, then it's going to be set to 0 initially. If I wanted to, I could set it to an initial value. So if there are like 20 students in here, I could say equals 20. And so this would be making a variable called num students, set it to 20. It can only store integers in it. Let's see. If I wanted to represent something like your salary, that's something that was probably not going to be an exact integer. So I might pick a data type like double and call it something like salary. And maybe it's set to something $19.75 an hour. So we have to pick the appropriate data type. If I did something like this, int salary equals 19.75, I'm going to have problems because I can't store 0.75 inside an integer. So make sure you pick the right data type that matches what data you want to store in it. Let's see, if we do strings, I use uppercase S in string, and then give it some name like food, and I could set it equal to something like, say, pizza. So this makes a variable called food, and then it's set to the string pizza. So just real briefly, let me go back to my program here and just make some variables. I'm going to get rid of those. So if I just do the ones we just started with, I could say int num students equals 20. If I want to, I can, on the next line, I could set it to something else. So the equals is the assignment operator. So it's not like equals in math where the left side is equal to the right side. This is really saying take whatever's on the right-hand side and then copy it into the variable on the left-hand side. And then if I do system.out.print line, I can print out num students. And so if I compile this and run it, then here it outputs 50 because I just copied that in there. If I do this, if I put double quotes around this and compile it and run it, then it doesn't output the variables values. It just outputs num students, the word. And so anytime you have double quotes, it's going to literally output that thing, not a matching variable name. And so sometimes you want to combine variable names with outputting strings, and you can do that by using a plus sign. And then I do a plus num students. So this is going to say the number of students is, and then the plus sign stands for concatenation. And so whenever you have a string with a plus, Java knows that you can't add a string. And so what plus means is just let's just glue together whatever comes next. And so num students comes next, and I don't have quotes around it, so it's going to look up the variable num students and see what its value is. And so if I run this one, then it says the number of students is 50. And then I could do more pluses. Let me do another one. Let's see, double salary equals 19.75. And I could say plus I could put a new line here because it's not inside the string. Oops, I messed up. And there are, oops. Okay. So now here we get, the number of students is 50 and their salary is 19.75. So we can output our variables in conjunction with strings if we want to. And then the last one I had here was a string, or in my other example, I had a string, so uppercase S for string, food, and I set it to pizza. And I'll just do a new print line. And so this will take whatever is stored inside food, stick it in at the end of the sentence. And so then we get their favorite food is pizza. Okay, so any questions so far? Okay, so I got one more section I want to cover and then I'll let you work on the lab part. And so let's talk about how we can do a little bit of math. And so when we have the math, these are called arithmetic operators. And so we have all the good news is they should mostly make sense. So plus is add, so that's good. It's not something strange. Minus is subtract. To divide, you use the forward slash. Although we have some caveats around divide we'll talk about here in a minute. Multiply is the asterisk. So real simply, I could do something like, let's see here. So if I have, if I make another variable, well, let's not even do that yet. I could say something like, well, I'll make another variable. So if we worked for 3 hours and you want to figure out how much money you'd have, then we'd multiply the salary rate by 3. So I could say, make a new variable called amount and set it equal to salary times 3. And then if I print it out, then up at the top here we get the 59.25 where it's multiplied those together. So you can do multiplication with a star just like you would probably expect. You could do other ones like pluses, so I could say like amount equals whatever, 3 plus 5 plus 2. So just like you would expect, it would add 3 and 5 and 2, and you would get 10. Let's see. Where do I do the press? So let me add in here that there's a precedence here. So the precedence is multiply and divide are done before plus and minus. And if they have the same precedence, then it's left to right. So in this particular example, here I have all pluses, and so this operation is going to be done left to right, and so it would be 3 plus 5 to give me 8, and then 8 plus 2 to get 10. But I could have different results, like what if I had 3 plus 5 times 2, then if I did this left to right, then if I do 3 plus 5 first, I would get 8, and 8 times 2 would give me 16. But if I do the multiplication first, then I do 5 times 2 to get 10, 10 plus 3 to get 13. So if you don't put parentheses in here, so you could put parentheses to force one way or the other. But if you don't have any parentheses, then Java uses these precedence rules, which says multiply first. And so Java would take 5 times 2 first to get 10, and then do 3 plus 10 to give me 13. Let's see. If I use divide, I could, pretty simply, like 10 divided by 2 would give me 5. There's another operator here we haven't mentioned yet, but we'll use a fair bit, and that's the modulus operator, and that's the percent sign. So modulus gives you the remainder after division, and it turns out this is actually pretty useful for all sorts of computing things. So for example, if I had 10 mod 7, then this would be saying how many times does 7 go into 10? It goes into 10 once with a remainder of 3, and so 10 mod 7 would give you 3. If I had 22 mod 7, well, 7 would go into 22 3 times with a remainder of 1, so then that would give you back 1. And so we'll end up actually using modulus later. If you want to, for example, make sure that you always get numbers between 0 and 6, then you could do a modulus of 7, and then you can possibly get a number that's 7 or bigger, since you'd always get the remainder. Okay. Maybe I'll leave that for later. So I guess just a precursor for what we'll get into more detail tomorrow is if I do things like this, like is sometimes we can get into trouble when we end up sort of mixing together different data types. So if I make an integer x, and I set x to 4 divided by 3, does anyone want to guess or know what value I would have in x? So mathematically, right, 4 divided by 3 would be 1 1/3, or 1.33333. But since x is an integer, it can't store the 0.3333 part. And so what Java ends up doing is it just truncates anything after the decimal point, and so it's going to end up just storing 1 inside x. So even if I had something that was like, you do division was like 1.9 or something, it's not going to round up. It just chops off whatever is after the decimal point. So anyways, because of this issue, you can run into certain problems, so we'll look more at that tomorrow. But before we do that, just a few other things I wanted to briefly mention is one of them is to worry about overflow. Let's see here. So here if I say int amount equals 10 times 10 and then print it out, and let me get rid of this stuff, then this should just print out 100, right? So there's the 100 like we would expect. What if I make these really big? Oops. And compile this one. then this might look a little weird. So I had these two big numbers that had all zeros in it, but somehow when I multiplied them and printed it out, I got 1874919,424. So obviously that's not correct. Anyone have an idea what happened here? Yeah.
You go past the barrier for the amount of numbers, and then it kind of like the end of the numbers float into memory because you couldn't store the correct amount
Yeah.
of numbers. It was like a buffer overflow.
Yeah, that's exactly what's right. It didn't go into other memory, and so what happens, so I tried to store a number that's too big for an int. The int could only store up to like 2 billion. And so what happens when you go beyond its size is it kind of cycles back to a negative number. So like if you got to positive too big, then the next number it would try to do would be like a negative really big number and then go through negative numbers. So you end up with some sort of random number if you exceed the size of the integer. And the little dangerous thing here is that there's no warning that it's going to happen. I just ran it and then you just get weird stuff. And so it would be up to you as the programmer to check your values to make sure that you don't have numbers that are too big that would cause problems. So it might seem like, oh, that's not going to be a big issue. It's not going to happen too often, but there have been cases where this kind of error has caused fatal crashes, and there have actually been cases where people have died because of situations like this. There's a radiation machine, the Therac 25, I forget what number it was, but it was a machine that would deliver little doses of radiation to treat cancer. But it was actually, there was a problem where the numbers would cycle through and would deliver doses of radiation that caused cancer. So people actually died, and it took a while to figure this out. So, okay, and so the very last thing, and then I'll stop, I think, here, is we also have these things, the increment and decrement operators. So plus is the increment operator, and minus is the decrement operator. And so the increment operator adds 1, and the decrement subtracts 1. And so it's pretty simple to use. You just put the variable name, like x, and then plus right next to it, or y and minus, and this would add 1 or subtract 1. And there's actually a difference if you put the plus in the front or the n, but in our case, we won't really, doesn't really matter for us, but if you have the plus on the end, then it's going to actually add after it does anything else on the same line. If you put it in front, like plus x, then it adds 1 first and then does whatever is on the same line. So there's a slight difference, but for our purposes, it doesn't really matter. So just to show that, if amount is 10, I say amount plus. So now amount becomes 11. And so there I see the 11 over there. I guess I should mention also, if I don't do an equal sign to assign things, then normally it doesn't change the variable. So plus is like a special case. So like if I just said amount plus 50, then here it computes amount plus 50, but it's never saved anywhere. I never did an equals to copy it someplace, and so it's going to compute 60, but then it just disappears into nowhere. So if I compile this, actually it gives me an error. So I have to assign it back to a value. I have to say amount equals that, to take the 60 over here and then copy it back into amount, to see the 61 pop up. Okay, so let me see here. Covered those. Let me just do one more practice thing here, and then let me look at the lab real quick, or the drill. So in the drill, yeah, that shouldn't be a problem. Okay, so one last thing. Here, let me just give you some things and see if you can figure out what x will be. So if we had this as our statement, anyone know what value we would get next? Yeah.
5.
Um,
All right, 3 divided by 6 would be like 1 plus 2 plus 1.
3 by 3. So it will do the division first. So remember our precedence rules. We divide first. So 3 divided by 6 would be a half in regular math. But, and here I only give you a little bit of this. But since both 3 and 6 are considered integers, it's going to do integer division. And so if you divide integer 3 by integer 6, then this would be 0.5, but as an integer, we throw away anything after the decimal point, and so it's just 0. So this right-hand side over here just becomes 0, and then you get 1 plus 2 plus 0, which gives you 3. So Java math is not identical to real math, so you have to be careful about some of these cases where you get this integer division stuff. What if we did it like this? Then we would get 1, yeah? So here this forces us with the parentheses, it forces this to be done first, so it adds these together, you get 6. 6 divided by 6 is 1. Let's see here, x equals 2 times 3 plus 4 times 5. So yeah, I heard someone say it, 26, and so we multiply before adding, and so I would actually do this one first to give us 6, then this one to get 20, and then add them together to get 26. Here's another one, x equals 4 by 2. So here's another one where mathematically it's different than what Java does. 0, yeah. So this would be done, well, we'll see. So this is done when you have this, it's left to right because the divide and multiply have the same precedence. So we do 4 divided by 2 first to get 2, and then we do 2 times 2 second to get 4, and then 4 divided by 4 so it actually gives us 1. So you get 1 as a result of this one. But if I flip this around, if I did it like this, where once again mathematically this should give us 1, but it doesn't because of what we're just saying. We do the 2 divided by 4 first, so this would give us 0. Then 0 times 4 is 0. 0 divided by 2 is 0. So you just get 0. Okay, so okay, I'll stop talking here and let you work on the drill for today. So any questions before we do that? Yeah.
My words were in red. Yours were in teal. What was the difference?
Oh, it's because I was using TextPad,
Okay.
I think. Yeah, instead of Dr. Java. So that should be it, yeah. Okay, so I'll get my sheet out when you're ready. Let me know and I'll come and mark you off.